Dear students, very good morning. Today we are going to see double integration under polar coordinates. Okay, double integration under polar coordinates. Okay, so already I have told you polar coordinates means it will involve r and theta. See, for example, if I am taking some x-axis and some y-axis, these two axes are represented as Cartesian coordinates. Okay, these two coordinates are represented as xy coordinate or Cartesian coordinate. Okay, Cartesian coordinate. Sometimes xyz will also be taken. Okay, in three-dimensional planes. Okay, in three-dimensional planes, those are called as xyz coordinates. Okay, so now similar to r comma theta, we will have sometimes in 3 dimension r comma theta comma phi coordinates also. But for you under polar coordinates, they will be called as spherical coordinates. They will be called as spherical coordinates. Okay, so now in polar coordinates we will have, see, if this is x and this is y, means I can take this x as r cos theta. Since this is x-axis, I can take this as r cos theta, and I can take the y-axis as r sin theta. So if I am drawing a line here, if I drawing a line here, and suppose this line, if this line is going like this, okay, and here is the point, means at this point you will have some similar reference, a reference to y-axis, and reference to x-axis. Am I right? A reference to y-axis and reference to x-axis. Okay, so here you will have some angle. This angle is called theta, and this distance is called r, and this distance is equal to r. When x can be represented as r cos theta and y can be represented as r sin theta, the line of length r will have angle theta. Okay, so this is usually used from change of Cartesian coordinates to polar coordinates. Change of Cartesian coordinates to polar coordinates, this can be used. Okay, for reference you can take a circle. Here is the center. Okay, here is the center. Okay, so here is your x-axis and here is your y-axis, means, see, this will be radius r. Okay, this will be radius r, and this will form angle theta in x-axis. Okay, this will form angle theta in x-axis. Okay, so not only in circle, in any geometrical figure you can create some reference to x and y with x equal to r coordinates and r cos theta and y equal to r sin theta. Okay, so with this basic knowledge, what we are going to integrate is, we are going to integrate a function of type f of r comma theta, a function of type f of r comma theta. So when you are having r, definitely you will have dr. When you are having theta, definitely you will have d theta. So since the first is dr, the dr limits will exist from r1 to r2, and the second integration is depending on theta, so the limits will be from theta 1 to theta 2. Okay, so in double integration we are going to integrate f of r comma theta with respect to r and theta between the limits r1 to r2 and theta 1 to theta 2. So that is the basic fundamental concept of polar coordinates. So you have to write this. So under polar coordinates we are going to integrate f of r comma theta with respect to r than with respect to theta. Okay, so with respect to r we will have the limits existing between r1 to r2 and theta existing between theta 1 to theta 2. Okay, so here you will have r1 less than or equal to r less than or equal to r2 and theta 1 less than or equal to theta less than or equal to theta 2. Okay, so when you are integrating with respect to r, theta acts as constant. When you are integrating with respect to theta, r acts as constant. What I am telling in words should be written in your notebook. Okay, what I am telling in my words, that should be written as a text in your notebook. Okay, so please write everything. Okay, so in double integration, the function f of r comma theta is going to be integrated with respect to r between the limits r1 to r2 and then with respect to theta between the limits theta 1 to theta 2. So r lies between r1 less than or equal to r less than or equal to r2 and theta lies between theta 1 less than or equal to theta less than or equal to theta 2. After that, on differentiate on integrating with respect to r, theta acts as constant. On integrating with respect to theta, r acts as constant. So these are the fundamental ideas that you have to write under the topic polar coordinates. Okay, double integration of polar coordinates. After that, draw this diagram. Okay, draw this diagram. Okay, here x can be taken as x equal r cos theta, y equal r sin theta. For understanding these students, you know the equation of circle x square plus y square equal to r square. You know that x square plus y square equal r square. Do you know how we got this equation? Generally, we will have x minus a the whole square plus y minus b the whole square equal to r square when center equal to a comma b and radius equal to r. Okay, but what I am telling is my question is how you got this. So center is 0 comma 0. Center becomes 0 comma 0 means you will get this. Okay, so let me tell you simply with reference to polar coordinates here. Generally we are taking x equal to r cos theta and y equal to r sin theta, because always the cos will be represented for horizontal travel and the sin theta will represent the vertical motion of any particle. Okay, under wave form. Okay, so with reference to that we are taking x equal to r cos theta and y equal to r sin theta. Okay, so here you will have x square plus y square equal to r cos theta the whole square or sin theta the whole square, that is equal to r square cos square theta plus r square sin square theta, that is equal to r square of cos square theta plus sin square theta, that is equal to r square, that is equal to r square. Okay, so this gives the formula equation of circle. When center is 0 comma 0 means you will have x square plus y square equal to r square. Okay, so sometimes you may shift your center. This is center 0 comma 0 for the axis. Okay, suppose I am taking my center here, here is entirely x, here is entirely y, the center is here a comma b means, so for this I will have a circle with center a comma b, I will have a circle. Okay, so from this point I will have the radius. Okay, so at this center maybe I will have the radius. So at that point of time I have to take x minus a, because and from the entire x-axis we have subtracted center 0. Now from the entire x-axis we are subtracting the some length in x-axis, that is a. So x minus a equal to r cos theta and y minus b equal to r sin theta. Now x minus a the whole square plus y minus b the whole square equal to r. Similarly you will get r cos theta the whole square plus r sin theta the whole square, that is equal to or that implies x minus a the whole square plus y minus b the whole square equal to r square, because cos square and sin square will come, both the sum of cos square plus sin square will become 1, so we will get r square. Okay, so this is that equation. Actually we are having a separate equation for the representation of circle having h and g. Okay, I think it is g and h. Okay, that is called general equation of circle. So the general equation of circle is what we are going to discuss now. So let me take this as f and g. Okay, not h and g. For my easy reference I am taking it as f and g. So how we are going to use this in our case? Okay, so here in this equation, in this above equation, you are having x minus a the whole square plus y minus b the whole square equal to r square. So this can be expanded as see, x square then minus 2ax, okay, and plus a square, okay, and this is plus y square minus 2by plus b square equal to r square. Okay, now this can be written as x square plus y square then minus 2ax, okay, x square plus y square minus 2ax minus 2by then plus a square plus b square minus r square equal to 0. So I am taking now 2a minus 2a equal to I am taking minus 2a equal to 2h or 2g, okay, and minus 2b, okay, minus 2b equal to 2f, okay, I am taking minus 2a equal to 2g and minus 2b equal to 2f, and after that I am having a square plus b square minus r square, that is as my constant, okay. So see, so substituting these three things okay, substituting these three things in the above equation, I will get substituting these three equations in the above equations, I will get x square, plus y square plus 2gx plus 2fy then 2gx plus 2fy plus c equal to 0. This is the general equation of circle. This is the general equation of circle. General equation of circle. Okay. So this is just for understanding how we are obtaining all these things. So deriving, we have derived equation of circle from the formula with reference to x equal r cos theta, y equal r sin theta. Okay, and we have derived the general equation of circle from this equation. In some textbook, the people used to take it as x minus h the whole square plus y minus k the whole square equal to r square, some textbook. Okay, so here you will have, instead of a you will have h, instead of b you will have k. So instead of a you will have h, and instead of b you will have k. So then also you will get the same equation. This is the general equation of circle. Okay, so with this introduction to double integration under polar coordinates, now we are going to shift to two important case, that is depending on the limits. Okay, depending on the limits. Okay, so double integration under polar coordinates. Okay, double integration under polar coordinates. Okay, under polar coordinates with constant limits, and another one is variable limits. Okay, so these are the two things we have to discuss. So first let me tell you an example. Okay, so evaluate, and this problem is very important. Evaluate integral 0 to pi by 2 integral 0 to infinity r divided by r square plus a square the whole square dr d theta. This problem is very important. Okay, now dear students, now see the solution. See here, always we will have the external limit as infinity and inner limit as something else. Okay, but here you should not see like that. What you have to see is whether it is in correct form or not. It should be in correct form. So when you are integrating with respect to r, means r should be a constant value. R means radius. So from 0 to infinity anything can be there. From 0 to infinity anything can be there. Okay, anything can be there. And theta means that it should be an angle. From 0 to pi anything should be there, or minus pi to plus pi anything can be there. Okay, anything pi will be there, or minus 2 pi to plus 2 pi. Okay, minus 2 pi to plus 2 pi anything can be there. Okay, so you have to know what is pi. Pi means 180, pi by 2 means 90, 2 pi means 360. Okay, so you have to aware that anything that in terms of pi, in terms of angle should be there in terms of limit, for the limits when we are considering theta. Okay, so here the limits are constants. So under the first integration with respect to r, so it's fine, correct. The second integration is with respect to theta, and the limits are with respect to angles, so it is also correct. So it is correct form. The limits and the integration are, so this is in correct form. Okay, so solution, let I equal to integral 0 to pi by 2 integral 0 to infinity r divided by r square plus a square the whole square dr d theta this is given, and this is in correct form. Okay, now so we have to keep the external limit as it is, and you have to integrate the inner limit and inner integral. So integral 0 to infinity r divided by r square plus a square the whole square dr, okay, into here you will have d theta. So that is equal to integral 0 to pi by 2. So here you have to think about something. It is very complicated to integrate it directly, because in the numerator you are seeing r, in the denominator you are having r square plus a square the whole square, r square plus a square plus, so and these two are added, so r square plus a square whole square. So it is highly complicated to integrate this. So how to integrate? You have to think, I am having r square and integrating with respect to r, I am having r also. So only r will be the constant, and any other term that is not involving r will act as constant. So this a square is constant. So don't bother about this constant. Okay, it is something called constant. Okay, so now we are having r square. Okay, and in differentiating r square, what will you get? On differentiating r square, you will get 2r dr. Okay, on differentiating r square, you will get 2r dr, but we are having only r dr. If I am able to have 2r dr means I can simply replace with the derivative of r square. Okay, simply replace numerator with derivative of this r square. Am I right? So what I am telling is here you can take let, okay, let us write here okay, let me write here that let r square equal to t. Okay, r square equal to t, then 2r dr equal to dt. 2r dr equal to dt. Okay, now we have to check the limits. Okay, because we are transforming the function from r to t. Okay, see, the entire thing going to become the function of r will going to become function of t. Okay, so we have to change the limits also. So here you will have r and here you will have t. Okay, so the limits of r are 0 to infinity. When r equal to 0 means 0 square equal to t, so t is also 0. When r equal to infinity means infinity square is also infinity, so t is also infinity. Therefore there is no change in limits. So we can substitute it as it is, integral 0 to pi by 2 into integral 0 to infinity. What we have done is we have to substitute for t. Okay, we have to substitute for t, r square equal to t, so t plus a square. Okay, t plus a square the whole square. Okay, t plus a square the whole square, and in the numerator we are having r dr, but we are having 2r dr. So r dr will be equal to 1 by 2 dt. So here I will have 1 by 2 and dt. So close this and then put d theta. Okay, now you can take this 1 by 2 outside. Now you can take this 1 by 2 outside. Okay, so 1 by 2 integral 0 to pi by 2, then integral 0 to infinity. This can be taken to the numerator, t plus a square, okay, t plus a square whole power minus 2 dt into d theta, dt into d theta, that is 1 by 2 integral 0 to pi by 2. Here you will have the integration x power n. Integration of x power n is x power n plus 1 by n plus 1. So you will have t plus a square whole power minus 2 plus 1. So minus 1 by minus 1, x power n plus 1 by n plus 1. Then the denominator you have to put the derivative. Okay, you have to differentiate this function. Okay, you have taken the entire function as x, so you have to differentiate this function separately. That will give you 1. A square is 0, a square is 0. Okay, so this is this. Okay, then you are having d theta. After this you are having d theta. Okay, now you are going to solve this. Okay, so that is equal to 1 by 2 integral 0 to pi by 2. So here you are having this minus will come outside. Okay, and this will become 1 by t plus a square into 1 by, this is same thing, into d theta, that is equal to, what is constant? The entire thing is constant. The entire thing is constant. Okay, but what we have missed is, we have forgotten to substitute the limits. Okay, you have to substitute the limits 0 to infinity. Okay, that is very important. So here 0 to infinity. Okay, you have to substitute and d theta. Okay, so here you will have minus 1 by 2 integral 0 to pi by 2, 1 divided by infinity plus a square minus 1 divided by 0 plus a square, upper limit minus lower limit, into d theta. Okay, so infinity plus anything will become infinity, infinity plus anything will become infinity, 1 by infinity will become 0, 1 by infinity will become 0. So you will have 1 by 0, so 1 by infinity will become 0. So it is simply 0 minus 1 by a square. Okay, 1 by a square into d theta, that is equal to minus 1 by 2 a square is here, and this minus will come outside, it will become 2a square. So 0 to pi by 2 into d theta, that is equal to 1 by 2a square into theta. For theta I have to substitute the limit 0 to pi by 2, so that is equal to 1 by 2a square into pi by 2 minus 0, that is equal to pi divided by 4a square, pi divided by 4a square. This is the required solution. This is the required solution. So you have to thorough with the concept. You have to be thorough with the concept and the problems. Okay, so this is one fine example and one important example for double integration under polar coordinates with constant limits. Okay, so now next we are going to see the double integration under double integration under polar coordinates, okay, under polar coordinates, okay, with variable limits, okay. So this is very important, okay. So when dealing with the variable limits, you have to know one important formula, that is integral 0 to pi by 2 is there, okay. So when the limits are from 0 to pi by 2, I am telling only when the limits are 0 to pi by 2, you will have sine power n theta, okay. This n can be anything, but it is a constant. It is sine, it may be sine squared, it may be sine cube. For n equal to 2, 1 to 3 and so on, you will get sine power n theta. Then d theta will be equal to 0 to pi by 2 cos power n theta d theta, cos power n theta d theta, okay. So you have to understand this, okay. You have to understand why I am telling this, okay. So here these two are equal, okay, these two are equal. So what to do from these two? So when you are how to integrate this means, there is no need to integrate. There is a formula already when these two things are given, or one of these two things are given, okay. So here the formula is common. So the formula is into 0 to pi by 2 sine power n theta d theta will have the same formula. Yes, into 0 to pi by 2 cos power n theta d theta have, okay. These two things will have the same formula, okay. So here n is there, no. So the formula is based on when n is even, when n is even, you will have one formula. When, okay, when n is odd, you will have one formula, okay. So when n is even, you will have n minus 1 by n, okay, n minus 1 by n into n minus 3 by n minus 2 and so on, etc. into 1 by 2 into pi by 2, okay. So this is the formula, n minus 1, n minus 3, etc. up to 1, then n minus 2, okay, n minus 2, etc. into 2 into pi by 2, okay. When n is odd, you will have n minus 1 by n into n minus 3 by n minus 2, etc. into, instead of 1 by 2, you will have 2 by 3 into 1, okay. Instead of pi by 2, you will have 1. So the formula is common for integral 0 to pi by 2 sin power n theta d theta and 0 to pi by 2 cos power n theta d theta also, okay. This formula will come when n is even, this formula will come when n is odd, okay. Now under this we are going to see a important problem, okay. So take down the problem, okay. So the problem is evaluate integral 0 to pi by 2 integral 0 to sin theta or dr d theta, okay. So first thing is you have to check whether they are in correct form or not, okay. You have to check whether they are in correct form or not, okay. So how to check that? See, you should not get confused. Here the limits are variable limits. So in double integral f of x comma y dx dy, how we identify the correct limit? Since it is x, means you can have here phi 1 of y2, phi 2 of phi, and here it may be constants, okay, a to b or something, okay. So it is functions means it should be a function of the second operator, okay, second integral operator. So second integral operator is with respect to y, and the first limits also should be with respect to y, okay. When you are having f of x comma y dy dx means here you should have phi 1 of x2 phi 2 of x, okay. This is what we have seen. Here you may have a to b. So the limits are with respect to x means the first integration should be with respect to y. In the same way, the limits are with respect to theta means the first integration should be with respect to r. The limits are with respect to you have to say constant means, okay, the first integration with respect to theta, okay. So here it is in correct form, it is already in correct form. So solution it is given I equal to 0 to pi by 2 integral 0 to sin theta or dr d theta. What is this given? Whether is it in correct form? Yes, the limits are with respect to theta, so the first integration should be with respect to r, so it is in correct form, okay. So correct form, okay. Now the integration of r will give integral 0 to pi by 2, integration of r will give r square by 2, okay. X power n means x power n plus 1 by n plus 1, so r square by 2. The limits are 0 to sin theta, the limits are 0 to sin theta into d theta, that is equal to 1 by 2 can be taken outside, okay, 1 by 2 can be taken outside, so you will have 1 by 2 into integral 0 to pi by 2 sin square theta minus 0, sin square theta minus 0, okay, into d theta, okay. So now you will have I equal to 1 by 2 integral 0 to pi by 2 sin square theta d theta, okay. So what you have is integral sin square theta d theta, So how to integrate this? So there is no need to integrate because you are already having the formula that here n equal to 2 means even means your formula is n minus 1 by n into n minus 3 by n minus 2 etc. into 1 by 2 into pi by 2 is your formula, okay. Am I right? This is your formula, okay. So here the integral will have n equal to means 2 minus 1 by 2 into 2 minus 1 to 2. Negative terms will not come. So when you substitute n equal to 2 means from this side you will have negative terms, so there is no need to substitute that. So here you have to check 2 minus 1 is 1 by 2, so it is 1 by 2 into pi by 2, that is equal to 2 minus 1 is 1 by 2 into pi by 2. If it is 4 means you will have 4 minus 1, so 3 by 2 then 1 by 2 then pi by 2. If n is 4 means you will have 4 minus 1 by 3, no, so you will have 4 minus 1 by 4, so you will have 3 by 4 and after that 1 by 2, okay. Then at last you will have pi by 2. When n equal to 4, what I am telling is, when n equal to 4 means you will have 3 by 4 into 1 by 2 into pi by 2 when n is 4. When n is 2 means this 3 by 4 will not come, only 1 by 2 into pi by 2. So the solution is I equal to, already there is 1 by 2 into, here you will have 1 by 2 into pi by 2. So the solution is I equal to pi divided by 8. The solution is I equal to pi divided by 8. Okay. So this is the required solution. This is the required solution. So dear students, just to keep in mind, the formula is depending only for the limits 0 to pi by 2. For other limits you have to integrate and you have to substitute the angle. Okay, when I'm having 0 to pi means you have to substitute the limits directly after integrating. Okay, so now we shall move on to the second problem. Now we shall move on to the second problem. Now we shall move on to the second problem under variable limits. Okay, the second problem is take down integral, evaluate integral 0 to pi integral 0 to a cos theta, then r sin theta, then dr and d theta. Okay, r dr into d theta. Okay, okay, so you have to check. Okay students, okay, before, instead of writing this, I am having r sin theta. Okay, r sin theta d theta into dr, r sin theta d theta into dr. Okay, so now we shall write a solution. What is given? I equal to integral 0 to pi integral 0 to a cos theta into r sin theta d theta dr is given. Okay, but you have to check whether the given limits and the order of integration is correct or not. Okay, so here the limits are functions of theta. The limits are functions of theta, which means you have to integrate with respect to r first. Okay, with respect to r first, but here it is theta, so it is wrong. So you have to interchange the limits. So you will have I equal to integral 0 to pi integral 0 to a cos theta or sin theta dr into d theta. Now the limits, first limits are the functions of theta, therefore first integration should be with respect to r. The second limit is with respect to theta. So after this you are having some constant limits. Okay, 0 to pi, this is angle. Okay, this is angle, so no problem, you can substitute. Okay, so dear students, suppose if you are having this is very important, when you are having functions of theta means you have to be very careful. Okay, so this is how you have to interchange the order of integration. Okay, now you have to integrate the terms with respect to r first. So integrating with respect to r means what will act as constant? 0 to pi. Okay, what will act as constant? Sin theta will act as constant, so r square by 2 into sin theta. Okay, so you have to substitute a cos theta and 0 into d theta, that is equal to integral 0 to pi r square by 2. r square is a cos theta, so r equal to a cos theta means you will have a square cos square theta into sin theta divided by 2 minus, when you substitute 0 means everything will become 0, minus 0 into d theta, okay, into d theta. Now okay, now you have to integrate the entire term with respect to theta. So here what are terms are constant? Here a square by 2 is constant, so before that I am writing it fully here. Integral 0 to pi a square cos square theta sin theta, a square cos square theta sin theta divided by 2 d theta. Okay, so this is what we are having. Okay, now I am going to substitute theta is there. Now I am going to substitute t equal to cos theta. Okay, t equal to cos theta, then dt will be given by dt equal to minus sin theta d theta, minus sin theta d theta. So I have to check the limits also. Because the entire function is transformed from theta to t, so it is theta and it is t. Okay, so when theta equal to 0, cos 0, what is the value of cos 0? Cos 0 is, okay, 1. Then when theta equal to pi, you will have, cos pi, cos n pi equal to minus 1 power n, so cos pi means cos 1 pi. This is the formula you have. Cos 0 equal to 0, then cos n pi equal to minus 1 power n. Okay, cos n pi equal to minus 1 power n. Okay, cos n pi equal to minus 1 power n. So when n equal to 1 means you will get cos pi, which means minus 1. So when theta equal to pi, you will get minus 1. Theta equal to pi means you will get minus 1. So here you will have, instead of 0 you will have to put 1, and instead of pi you have to put minus 1. So this a square by 2 will come outside. Okay, so cos theta can be written as t, so t square minus sin theta d theta is dt. Okay, minus sin theta d theta, so you have to multiply by 1 minus, so I am putting 1 minus outside and 1 minus inside. Okay, so that is minus cos square theta sin theta d theta. Now I will have minus a square by 2 integral 1 to minus 1. See, actually this is not correct because we have substituted limit now. So put 0 to pi here. Okay, 0 to pi. So minus a square by 2 cos square theta sin theta d theta. So now you can transform everything. Minus a square by 2 integral 1 to minus 1. Then after that you will have minus sin theta. This is cos square theta is t square minus sin theta d theta means it is dt. This is dt. So you will have minus a square by 2 into t cube by 3. T cube by 3, the limits are minus 1 and plus 1. So here you have minus a square by 2. So minus 1 the whole cube minus plus 1 the whole cube whole divided by 3. So you will get minus a square by 2 into minus 1 by 3, that is equal to, this is minus 2 and this is also minus, so minus into minus will become plus 2a square divided by 2 into 3. These two 2's will get cancelled, that is answer is a square by 3. So your answer is a square by 3. Your answer is a square by 3. So here comes the solution. So this is how you have to solve. Okay, so I am writing the important step hidden here that you have to understand. Here what I have done is, below this what I have done is minus a square by 2 integral cos square theta into minus sin theta d theta. Okay, so minus sin theta d theta is dt. So after that we are having this step. Okay, so minus a square by integral cos square theta means t square. So you have to use the correct way of substitution. Okay, then only you can able to solve the problem. Okay, now the today's homework. Okay, so today's homework is evaluate, first thing is evaluate integral 0 to pi by 2 integral a into 1 minus cos theta to a r square dr d theta, r square dr d theta. Here you may be required to use the formula a minus b whole cube. Here you may be required to use the formula a minus b whole cube. Okay, this is one thing. Second thing is you may be required to use that power, sine power and formula. Okay, whether n is even or you have to use that formula. So the answer for this problem is a cube. The answer for this problem is a cube. Okay, so this is your hint. You have to use these two things. Okay, then second one is second problem. Second problem is this problem is very simple. Integral 0 to pi, then integral 0 to sin theta or dr d theta, and for this the solution or the answer is pi by 4. Okay, third thing, the third problem is evaluate integral 0 to pi, then integral 0 to a, then r dr d theta or dr into d theta, and for this your answer is pi a square by 2, pi a square by 2. Okay, so complete these three homeworks. Okay, so dear students, I hope you all understand the problems and the basic concept about double integration under polar coordinates with constant and variable limits. So go through this and write everything, okay, because some of the thing I could say, but it is not possible to write, that you have to write. Okay, initially I have defined what we are going to do under double integration under polar coordinates, that is this. So this is what I have explained in words, okay, but I have not written anything here, but you have to write what I have told initially. So here we are going to integrate the function f of r comma theta with respect to r and then with respect to theta. So on integrating with respect to r means the limit should lies between r1 to r2, and integrating with respect to theta means the limit should lies between theta 1 to theta 2. Okay, so here when r is the function of theta means the first integration should be with respect to r. When the first r is the function of first limits are with the function of r means, that is constant means, you should have theta here. Okay, so you have to write everything what I have told initially. Okay, so I hope this video is very useful for you. If you also feel that the problems and the explanations are useful, please try to solve the 3 homework problems. Okay, so the main aim of my video is I am not able to teach each individual person one by one directly, but through this video, through this online platform like YouTube, I am directly coming to your home. I am directly coming to your mobile phones. Okay, I am directly, you can able to access my teaching whenever you are free. Okay, whenever you are free, whenever you feel comfortable. Okay, I am not, as a teacher, as a professor, I am not going to force you to sit for this particular class, listen to me. I'm not going to compel, because it is about your ways. If you want to improve your mathematical ability to solve double integration means, you can access this video at any time. Okay, so the students all over the world can access and get a fruitful benefit through these video lectures. Okay, so even if you have doubt means, you can directly ask me, or else you can comment there your doubt, whatever is your doubt. Let me contact you and clarify your doubts, or else a separate video will be posted in clarifying all the doubts at a stretch. Okay, so the main aim of my video lectures is to promote the mathematical knowledge to each individual student in this society. Okay, so thank you all for watching this video. Thank you all once again. Have a nice and great day. Thank you.